Right, so today what we plan to do is statistics, the question 5, right? So question 5, I believe that is a question where everybody could get at least, not at least, the full 9 marks. Once it come, how it usually come, right? And these days I find it tested a lot on probability. So the 5 questions I chose to do this, to do today for revision is a broad 5 topics that I noticed that it include a lot of stuff on statistics, right? So that's why it's those particular 5 papers I say we do it. 1, 2, 3, 4, 5, 6, 7. Somebody went off. Right. So the first set of questions we're going to look at is the ones I asked you all. I told you all that we wouldn't print, right? And then the last 3 we will do is the ones that I asked you all to print. So let me just quickly go through. The ones I asked to print were May, June 2019, January 2022, and January 2024, right? So we'll tackle those 3 last. So first up, we're going to look at Jan 2026, the most recent one. So in Jan 2026 here, we have, first question here was a pie chart. Some grade 11 students were surveyed to determine the job sector in which they are most likely to seek employment after graduating. Their choices are represented on the pie chart shown below. Right, so quick recap on a pie chart. We all should know by now that on a pie chart, the total angle on a pie and a circle is 360. So once we have a pie chart, we know the entire circle in here must add up to 360. So anytime we want to find a sector, we know that is the particular sector over 360 will give us the sector angle, right? If we want to find percentage, and then we need to multiply by 360, right? If we want to find percentage of something, percentage again would be what particular value of that sector over the total, and you multiply by 100. If we find in percent, we multiply by 100. If we find any sector angle, we need to multiply by 360 because that represents the whole. All right, so let's see the first question here. Calculate the percentage of students who are likely to seek employment within the agriculture and ICT sectors. So they want percentage, and they want within agriculture and ICT. So agriculture is 40.5 and ICT is 67.5, right? So they want to know the percentage of students within these 2 sectors. So we would add 40.5 and 67.5. 40.5 plus 67.5. That would be 108. So for this one is 108, which is the 40.5 plus 67.5 over, and it will be the total of the circle, which is 360, and you multiply by, since you want to find percent, you multiply by 100, and that will give us the answer for that first one. And we will get 30%. Next up, they ask to calculate the value of P. So let us see where they have P inside here. So in P, right, so they have a sector here as 4P, then they have 3P, they have 2P. So in this question again, we know the total circle is 360. So that means if we add up all these sectors in here and put it equal to 360, we could solve for P, right? So to do part 2, we would add up 4P plus 3P plus 2P plus 40.5 plus 67.5, which is 108 from before. And very importantly, don't forget about this one here, right? They didn't put the value, but they put a 90 degree. So make sure and add in that 90 degrees. So we total up everything within the circle and we equate it to 360. And then we would solve for P. 4 and 3, 7, 8, 9, 9P, 108 plus 90, 108 plus 90 is 198. We carry that across. 360 take away 198. Which is 162. And then to find P, we would divide by 9. $18. So we get P is equal to 18. Right, so that was a nice easy 5 marks there. The actual percentage, the actual defined value of P. So it's just knowing about how to deal with a circle pie chart, right? Part B now, we have a probability question here. So every time I look at this question, I just remember SCA type questions. Just exactly like this bring SCA questions. Instead of probability, this is use decimal fraction, which is basically the same thing. Liz has a set of red, yellow, and white buttons in a sack. So in the sack, we only have red, yellow, and white. So we know that if we combine these three, we will get a total, right? And for probability, we know the total for a probability is always 100% if we dealing with percentage, or if we dealing with fractions or decimals, it had to add up to 1, right? So it's either 100% or 1. So in this question, if we look at the information given, they give us it in terms of decimals, right? So in that case, everything had to add up to 1. So the probability that she chooses a yellow button is 0.3. The probability that she chooses a white button is 0.1. What is the probability that she would have choose a red button? So therefore, it's just the remainder, right? 0.3 and 0.1. We add these two and we subtract from the whole, which is 1. So to get red button would be the whole, subtract the yellow and the white. 0.3 plus 0.1, so 0.6. So the probability that Liz chooses a red button would be 0.6. And then part 2, if there were 80 buttons in the sack originally, determine the number of buttons that were red or yellow. Right, so if we have a total amount, and I want to know how much were red or yellow, we have the probability, or let me use the word decimal fraction of it. And so this will give us the parts of it, right? The part that is yellow and red. So red, we would have 0.6, and yellow, we have 0.3. So they want to know how much of a red or yellow. So red or yellow would be together 0.9. So 0.9 represents the amount in terms of percent and probability, or the decimal that is red or yellow. So if we want the number of buttons, the number of red or yellow would be 0.9 multiplied by the total, and that will give me 72 buttons. Right, so this was a pretty straightforward question. Any questions on this one?
No, sir.
No? Okay. All right. So next up, we're going to look at January 2025. Right. So here, January 2025, question 5. So now we have a table which shows marks out of 10 that 40 students in the class gained on an essay writing test. Right, so this type of information we have here is called ungrouped data. Why is it ungrouped data? Because our marks here, they have it as individual marks, right? So the next type of data that we could have is group data, where in that case the marks now will have intervals. And we have 4 to 6, 6 to 8, and so on, right? Once it's like that that is called class intervals, and that is group data. This type of question is on group data, right? Right. So these are the marks. These are the frequency. The frequency states how often these marks occur, right? So the questions they like to bring on this is most of the time mean, mode, median. So first up, we want to calculate the mean score. Mean score is given by the sum of fx over the sum of f. How are we going to get sum of fx? We need to look at our table. We have x and we have f. Fx, we will create a new column, fx, and we will multiply the f by the x. So 4 by 3 is 12. 9 by 6 is 54. 8 by 7 is 56. 8 by 7 again is 56. 9 8s are 72. 10 5s are 50. And then we need to total that up, right? We also need to total up our frequency. But in this case, they give us this here. They say 40 students in the class. So when you total up this, you're supposed to get 40. Right, so we need to total up the f of x, fx, and we would get, let's see, I got this already. $300. Right, so when we total fx, we get 300. When we total the frequency is 40. So the mean will be 300 over 40, and that is 7.5 marks. Right, next up here now, let me see what they ask now. Now they ask to find, let's go to the next page. Determine the modal mark. Right, so what is the modal mark here? The modal mark would be the mark that has the highest frequency, right? So always come to your frequency column first and look, what is the highest frequency here? 9. 9 is the highest frequency. So therefore the modal mark would be what this 9 referring to. This 9 refers to 6 marks. It means it had the 6 marks occurring 9 times. So our modal mark would be 6. Well, like 6 marks. And then they ask for median mark, right? So median, once we dealing with on group or group data, right, and we're not reading from a cumulative curve. When we're reading from a cumulative curve is a bit different. We will look at that when we're doing a question like that. So once we're dealing with a table and we have to find the median mark, that is given by n plus 1 over 2, where n is your total frequency, right? The total frequency in this question was 40, so therefore n going to be 40. So it's 40 plus 1 over 2, which will be 41 over 2, which will be 20.5 value, right? Please note that this is not your answer. This is telling you the position of the median mark. Just like the mode just now, we would go to the table and see what's the highest frequency and refer to the mark. Same thing with median. Once we do this, n plus 1 over 2 is the location of that value. So we need to go on our table and locate where it's 20.5. So scroll back up to the table. So 20.5, we would start on the frequency and start to add up. So here we have 3, here we have 9, so 3 and 9 is 12, 12 plus 8 is 20. So we reach 20, right? We're looking for 20.5. So the 20th value is 7, and then if we come down here, we have to add 7. So if this is 20 is 7, 21, 22, and so on is 7, right? So the 20th value is 7, and our 21st value is 8. So if we're looking for 20.5, 20.5 going to be in the middle. So you're going to be in the middle of 7 and 8. And what is in the middle of 7 and 8? 7.5. Right? So the 20.5 value would be in between 7 and 8. So we add the 2 and divide by 2 to find the middle of those. So we get 7.5 marks, which is the median. Right, so median is one of them that students mix up a bit, right? So if you're not sure, ask me, right? This is a question I like to bring nearly every year. Ashley, you go to the median? You go to the median? All right. Let me see what up next here. Right, so we have our next pie chart question here. Using the information in the table below, a pie chart is constructed to represent the marks students gained. So marks between x is between 3 and 4, we have 3 students. X between 5 and 6, we have 9 students. X between 7 and 8, we have 15 students. X between 9 and 10, we have 13 students. Calculate the angle for the sector representing the interval marks 5 to 6 in the pie chart below. Right, so we want the values that x is between 5 to 6, which is this row here. Right, we have 9 of those students over the total. So we need to add up all of this, right? They didn't give us any question? No, so we have to add it up. So 3 plus 9 is 12. 12 and 15 is 27. 27 and 13 is 40. Right, so it's 9 over 40. 40 is our total. So in this question, if they ask for percent, we would have taken the 9 over the total and multiply by 100. But in this question, they ask for the angle for the sector. So we need to multiply by the 360 degrees, which is the full circle. Right, so 9 over 40 by 360 will give me 81 degrees. Right, so this question they hit we are mean, median, mode. Now they hit us a part with a pie chart, small part. All right, let me scroll again and see. Oops, going too far. Right, and now they hit we with a probability here now. Right, the diagram below shows two fair six-sided dice P and Q. The 6 numbers on die P are 0, 0, 1, 1, 2, 3. So these are the numbers on this dice here. The 6 numbers on die Q are 1, 1, 1, 2, 2, 3. That's the numbers on this one. When a die is rolled, the score is the number on the top face. Right. So the top face is the score. Okay. Die P is rolled once. What is the probability that the score is not 2? So if they roll die P and they want a probability that is not 2, therefore it's going to fall on all the numbers beside 2. Right? The chances to fall on all the other numbers except 2. So all the other numbers, they are 1, 2, 3, 4, 5. So there are 5 possibilities for it to land on over the total amount of numbers. There are 6 numbers, so that would be 5, 6. Or we could just find the probability of it occurring, which is at 2, which is 1, 6, and subtract it from the whole, which is 1, 1 minus 1, 6, and we will still get 5, 6. So either way, we could look at that question. Right, part 2, die Q is rolled twice. What is the probability that its score is 1 both times? Right, so in a probability question, once we have events occurring more than once, so in this question they say it rolled twice, right? So these are called independent events. Sometimes they would tell you it rolled twice, sometimes they would use the word and, sometimes they would use the word then. So anytime we see something happening more than once, or they use the word and or then, they call it independent events. And to find this one out, what we need to do is define the probability of them occurring each time, and then we need to multiply them, right? So the die Q is rolled twice, and I want the probability that the score is 1 both times. So on the first throw, we find the probability of our 1 occurring, and this is what is Q. So Q is this die. The probability of our 1 occurring is we have 3 ones out of 6. So it's 3 out of 6, which is a half. So the first dice, the probability of 1 occurring is a half. On the second roll, the probability of our 1 occurring will be the same half again. Right? And the probability score is 1 both times. So the probability of our 1 both times would be we multiply the two probabilities. So again, anytime we see an event happening more than once, or they use the word and or then, find the probability of them, each of them individually, and then multiply them. So we will get a quarter. Right, what next here? This question long way. Die Q is rolled 72 times. Calculate an estimate of the number of times the score is 3. Right. So now they're telling us they're rolling this die 72 times and they want to know how much time we expect it to land on a 3. Right? So notice they use the word estimate. Obviously is not something that's going to happen in real life. If you roll this die 72 times, the answer we get going to work out here wouldn't really be the answer you'll get in real life. But it's an estimate. Right? So to calculate the estimate, what we need to do this in this question, we need to first find out the probability of getting a 3. So the probability of it landing on a 3, this is die Q. The probability of it landing on a 3, die Q, it has 1, 3, and it has 6 numbers. So that is 1, 6. So the probability of a 3 is 1/6. And then the estimate would be the probability of occurring once multiplied by how much times it roll. So that is 12 times. Right, so if you're rusty in probability, make sure and do some revision on this. Based on trend, they bring in this a lot these days. And they be prepared for everything. Alright, we see what next. The continued probability again here. Right, so this question, they use this diagram here to throw you off, but it's not really anything too complicated. Each die is rolled once the product of the scores is recorded. The sample space diagram is shown below. Right. So in this diagram, they had die Q and they had die P, and they're just saying they roll the die, and then what happened? They're taking the two numbers and multiplying them and filling out this diagram, right? But don't let us complicate it. Look at what they're asking here. Find the probability that the product of the scores is a 2 or a 3. So basically, they want you to go through here and see what is the probability of seeing a 2 or a 3. So in probability, when you see the word or, that means we need to add. Similarly, before when we see the word and, which is independent events, we have to multiply. When you see or, we need to add. So we could do this two ways. Find the probability of a 2. So we go through here and we see how much time we see 2's. 1, 2, 3, 4, 5, 6, 7. So it has 7 2's out of, and we have 36 combinations in here, right? And then the probability of seeing a 3, we count number 3's. 1, 2, 3, 4, 5. We have 5 3's out of the total of 36. And the probability of a 2 or a 3 would be, when we see the word or, we add. Seven over 36 plus 5 over 36 is 12 over 36, which is 1/3. Right, so that is one way of doing it. And next way of doing it is, if you want the probability of 2 or 3, just add how much 2's and 3's we seen in here one time instead of separating it out. So we count how much 2's and 3's in total. When we count up in total here, we will get 12 2's and 3's together. And we say 12 divided by the total number of combinations here, which is 36. 12 over 36, and we get the 1/3 one time. Alright, so we finally come to the end of that question. Right, any questions on this one? Nobody questions? Tashana, how are you going?
So I was not going to ask if you could just explain over this piece one more time, please.
This one I just did?
Yes, sir.
Okay. Alright, so I'll explain, let me do the easiest way, right? The easiest way, when they ask you now, they want the probability that the product of scores is 2 or 3. So what they're asking for is how much times you're seeing 2's and 3's inside this diagram, right? This die Q, 1 second. Yeah, come in. Oh. Get it, take one of people there, right? Yeah, so this part of the diagram and this part of the diagram, we're not going to count, right? These are the numbers on the die that they multiply to fill in this diagram, right? So we ignore this and this. So they want the probability that we see in a 2 or a 3. So we come on the diagram and we count how much 2's and 3's there are. So if we go through this diagram, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 possibilities of finding a 2 or a 3 inside this diagram. So since we have 12 possibilities, and we always divide by the total number of possibilities. The total number of possibilities will be the total number of blocks in here, which is 36. And 12 over 36 is 1/3. Understand all better there?
Yes, sir.
Yeah? Okay, good. All right. So up next would be January 2021. Right. So let me see what this question. I think I'll give all you some time to do this one. Can't be doing all the work myself. Right. So we have a table with on group data, and it asks mean, median, and mode, and then we have a pie chart. All right. So I've given you all 10 minutes. 10 minutes too long for this, but I'll give you all 10 minutes. 5:06. So when it's 5:16, I will correct this one, right? All right. So we're going to look at correcting January 2021, question 5, all right? Right. So, hey, we didn't have to, just now we add up the frequency. You see, sometimes you don't have to add up. Look in this question here. They tell you 60 students. So sometimes read the question, right? The question is save you some time from adding up this column here. All right. So 60 students took an algebra test which comprise 15 multiple choice questions. The number of correct answers that each student obtained is recorded in the table below. Right, so this column here is the number of correct answers. This column referring to the number of students that got these answers correct, right? So this is like a frequency. So here's your frequency, and there's your x. Using the table, determine the number of students who are exactly 13 answers correct. Well, 13 answers correct refer to 11. So we have 11 students. The modal number of correct answers. So the modal, we would look for our highest frequency. Highest frequency is 14. This 14 refers to 9 correct answers. So our modal number of correct answers would be 9 answers, correct answers. Right, so pretty straightforward, 1 marks there. Median number of correct answers. So median n plus 1 over 2. N in this question is the total frequency, which is 60, which is the 30th.5 value, right? So again, that is not the answer. We need to go and locate where this 30.5 falls in, right? Right, so we go back to the table and we start checking. 6 plus 14 is 20, 22, 28, 30. Right, so we find the 30th value. The 30th value is 12, and therefore from the time we go into this row, this will be 31 and onwards, right? So the 30th is 12, and the 31st will be 13, so the 30.5 will be between these two numbers. So 12 plus 13 over 2. 12 plus 13 over 2, and I will give my 12.5 correct answers. Right? So make sure you know how to do mean, median, mode. Right? Straightforward question to get you easy marks in. Next up here, the probability that a probability that a student chosen at random had at least 12 correct answers. So at least means greater than or equal to 12 correct answers, right? So we want 12 or more. So we start to see how much students got 12 or more. So we'll go back to the table. So 12 or more, 12 correct answers is 12. So 12 or more would be these numbers here. So that is 20, that is 32. So 32 students got more than 12, and since they're asking for probability, it will be 32 over the total. The total is 60, right? And we could reduce that as 8 over 15. Right? Don't worry to put your answer in long decimals and round off anything, right? Always leave it as a fraction for probability. It's easier that way. Right, up next, pie chart again. A group of students wrote a physics examination. Each of the students achieved a grade 1, 2, 3, or 4. The pie chart below shows the results. 1, 2, 3, 4. We have no information here, no information here, no information here. We have information for this sector here. 39 students achieve a grade 3. Determine the total number of students who wrote the examination. Right. So anytime we need to find out the total population in a pie chart, right? And all we have is the information for angle and how much that angle referred to, we equate these two together, right? So what we could say here is 117 degrees represents 39 students, right? 117 represents 39 students. And if they want the total number is when we find for 360 degrees, right? That is the whole. So if 117 is 39, we have to find how much 360 is. So how we will do this is, we will find for 1 degree first. 1 degree will be 39 over 117. And then we will find for 360 degrees, which is the total. So it will be 39 over 117 multiplied by 360. Right, and that will give me 120 students. Right, so the total number of students is 120. Right, let me look at this other part. The ratio of the number of students who achieve a grade 1, 2, or 4 is in the ratio 2 to 4 to 3. A student passes the examination if he or she achieve a grade 1, 2, or 3. How many students pass the exam? Okay. So if they want to know how much students pass the exam, we need to know how much got grade 1, how much got grade 2, how much got grade 3, and then total them up. Now they give us a ratio here, 2 to 4 to 3. So 2 to 4 to 3. 2 is grade 1, 4 is grade 2, and 3 is grade 4. Right? And when we deal with ratios to find grade 1, so for grade 1 would be 2. There's 2 parts out of the total. The total parts is 4, 5, 7, 8, 9 parts, right? So grade 1 is 2/9 multiplied by something. Grade 2 will be 4/9, 4 out of the 9 multiplied by something. And grade 4 is 3 out of the 9 multiplied by something. What we have to multiply by? When we find in ratios, we have to multiply by the total amount of students, right? But in this question, the ratio here specify only grade 1, 2, and 4. So in other words, we need to get the total students who did grade 1, 2, and 4 alone. So if we go back to the pie chart here, they told us 39 students got grade 3. So therefore, if we want to know how much students got 1, 2, and 4, we will take this 39 and subtract it from the total of 120. So 120 take away 39 will give us how many students had a 1, 2, or 4, right? So this question had a little trickiness in it here. So 1, 2, or 4 will be 120 take away 39, and that will give me 81. Right, so 81 students is the amount of students who got 1, 2, and 4. So now this is what we're going to distribute this ratio with. So 2 nines times 81, 4 nines times 81, 3 nines times 81. 2 nines times 81 is 18. 4 nines times 81 is 36. 3 nines times 81 is 27. Fine, it's plenty working for this 2 marks, but let me can only work for this 2 marks. How many students pass the examination? So which students pass now? So to pass the exam, you have to have a grade 1, 2, or 3. So grade 1 is 18, grade 2 is 36, and don't fall for the trap and go and put 27 in here, right? Grade 4 is not a pass. Grade 3 is the pass. So we have to use 39 that they give us in the pie chart for grade 3, plus 39. So these are the students that pass, 18, 36, and 39, which is 93 students. All right, anybody get this part of this question?
Yes, sir.
Yeah, all right,
Yes,
nice,
sir.
good. And then part 3, determine the value of the angle for the sector representing grade 1. All right, so grade 1 is 18 students, so we will say 18 over the whole. The whole is 120, that is the total amount of students. And since they want angle, we would multiply by the total angle in a circle, which is 360. 18 over 120 by 360 is 54 degrees. Right, so where we reach, right, so the end of this question, all right? Yeah. Okay, any questions on this question? Everybody handle it okay? Okay. All right, so up next, we're going to start the questions that I asked you all to print, right? The ones that we have to draw and interpolate from and things. So this will be group data now. So group data where we have these intervals, class intervals, right? So we're going to have to find mean, mode, median using group data on a table, and is not much different to what we just did, right? Basically the same thing. Instead of an answer that we have given as a single number here, now we have them as an interval. So your answer will be within an interval. All right. So this is Jan 2024, question 5. The mass M in kilograms of 120 newborns at a hospital is recorded in the table below. Right, we have the information in the table. And they ask us to state the modal class. So what is the modal class? Ricardo, what is the modal class there? Hmm? We have to look for. Which number is the highest frequency there? 30. And what 30 referring to? 4.4 to 5.3, right? So we come in the frequency column, we look for the highest frequency, and that's referring to this mass here. So this here is our modal class, right? So our answer there would be 4.4 less than m less than or equal to 5.3. And it's kilograms, right? Okay. Then next up, we would have complete the table below and calculate an estimate of the mean mass of the 120 newborns. Right. So the next thing students is doing this question, they don't read, they will fill out this table and think they're done and forget this part here. They're actually asking for mean mass, right? So don't forget that out. Most of your marks is this part. To follow this table might be 1 mark, and that mean will be the next 2 marks, right? Right. So when we have class intervals, we need to be able to find the midpoint. Why we need to find the midpoint? Because when we find in our mean, which is your frequency times x, we can't take the frequency and multiply by this interval, right? If it was on group data, we would have one number here and we would just multiply it. But since it's group data, we have an interval, we need to find the midpoint. Right. So the midpoint is given by when you add these two numbers and you divide by 2, we will get the midpoint. So therefore, to fill out this missing information here, we would add 5.3 and 6.2 and divide by 2, and we will get 5.75. Similarly, here we would add 7.1, add 8, and divide by 2, and we will get 7.55. Right? So remember to get midpoint, you add the two numbers in your class interval and divide by 2. And then now, remember to fill out this missing information here. This is your frequency times your midpoint. So this is your midpoint, multiply by your frequency. So you multiply these two numbers, you multiply these two numbers. 5.75 by 29 is 166.75. 7.55 multiplied by 8 is 60.4. And then they ask to calculate the mean mass. So mean is given by sum of fx over sum of f. Sum of fx, we would add up our fx column here. Right, when we add up that 651.3, and the total frequency, again, don't want to waste time adding this up. The total loss is 120 newborns, so our total frequency is 120. So mean would be 651.3 over 120, which is 5.43 kilograms. Right, easy, 1 mark and 3 marks, nice easy 4 marks again. So let's start the question to get the marks in. Right, now we have the next is a probability, so this will be a simple probability, right? One newborn is chosen at random. Find the probability that the newborn has a mass greater than 5.3. So the probability of a mass greater than 5.3 is how much newborns actually greater than 5.3 over the total. So let me see how much greater than 5.3. Right, so in this interval here, m is in between 4.4 and 5.3. from this one here now, m is greater than 5.3. So therefore, we would want all the numbers that greater than 5.3, which represent these numbers here, 29, 28, and 8. So these three here would be greater than 5.3. So 29 plus 28 plus 8 is how much? 65 over total. 65 over 120. And as I said, don't change the decimal, just reduce it to the lowest term in a fraction, 13 over 24. That's all I'm looking for. Right. Part B, complete the cumulative frequency table shown below. Right, so let me just write the frequency next to it from the table. So the frequency, this is from the table above, I just filling in here, right? So I want to be doing going back. 7, 18, 30, 28, and 8. Right, so cumulative frequency is a running total of the frequency, means we basically add in the number and what come before, right? So this 7 and this 7, nothing come before, so this 7 will come back here. To get this number, we would add 18 plus the 7 to get 25. Then to get this number, we would add the 30 and what come before to get the 55, right? So to get this number here now, we would add 29 and what came before. Well, what came before is this number here, 35. So you can just add 55 and 29. And that will give me 84. And this number, we would add 28 and all that come before, or 28 and 84, which is 112. And then the last one, we would add 8 and all that come before, or 8 and this previous number here, 112, that will give me 120. Right, so remember, cumulative frequency is a running total of all the frequencies and what came before. Right, and then up here now, they want us to plot it on this graph here now. Right, so they did 3 for us already. They did the first 3. So we have to do the others here now. So they had, this is 0, then they had 3.5 and 7. Then they had 4.4 and 25. So now we have to do 5.3 and 55. So let me figure out what these small blocks is here. In your y-axis, the cumulative frequency, the difference between this is 10 and it's 5 blocks, so like 2. So each of these small blocks is 2, right? So there's 10, 12, 14, 16, 18, 20. So this is in 2s. And in this direction, this is 3.5 and 4.5. So the difference here is 1. And we had 10 blocks, so that is 1/10. So each of these is going to be 0.1, 3.6, 7, 8, 9, 4, 4.1, 4.2, 4.3, 4.4. Right, good. So each of these small blocks here going in 0.1, and everyone in this one going in 2. But that's how we remember it, right? Right, so we have to put in 5.3 and 55. So 5.3 would be this block here, and 55 would be in the middle here. This is 52, 4, 6, so it will be here. Let me zoom in a bit here, yes. So that will be there. And then the next one is 6.2 and 84. So 6.2, this is 5.5, this is 6, so 6.1, 6.2, and how much? 84. This is 82, 84. So we put our point there. And the next point is 7.1 and 112. This is 6.5, this is 7, 7.1 will be here. And we go into 112, this is 110, so this here is 112. And then the last one will be 8 and 120. So 8 here and 120. Wait, slow down. 120. Right. So after we plot the points, my graph might not come out too good in this, but I'm not trying. Connect all the points. I remember it's not a straight line, you're connecting with a curve, right? Take your time, draw your curve. Right, connect with line, connect with dots, we plot the curve. So put in your points. Right, I'll give it a couple minutes to catch up on the curve, right? See what that asks next here by the time. Use your diagram to estimate the median. Okay, median.
So,
Yeah.
can you go back to B part 1, please?
B part 1.
Yeah,
B part 1. B part. The cumulative?
yeah,
Okay. So to get cumulative frequency is a running total of all the frequencies, right? So let me look. Let me do it up in this table here. Actually, we had that table. Okay. So if I want to create the cumulative frequency, what I need to use is this column, which is your frequency, right? So the first number in your cumulative frequency will always be the same as the frequency. So that will be 7. The reason being, cumulative frequency is when we add in the numbers in the frequency and what come before. So here we have 7 and we have nothing before. So 7 will be 7 here. To get this next number here now, we need to add the frequency here, 18, and what come before. So this is 18 plus 7, and we'll get 25 here. Then to get this next number in the cumulative frequency, we will add the 30 and what came before. So 30 plus 18 plus 25. Or we know in the cumulative frequency this 25 referred to what we already summed before, right? So we could just add this 30 and this 25 here to get 55. You follow that so far, Justin?
yeah.
Yeah? Right. So now to get this missing number, right? So I've shown you two ways, right? So to get this missing number here now, we will take the 29 and add it to 55. And we will get 84. Or we take this 29 and we just add all that come before. 29 plus 30 plus 18 plus 7 and we will still get the 84. So tell me how to get this one here now.
28 plus 84 plus 29.
No, by adding the 20. So listen again, right? I'm showing you two ways to do it. Don't mix up the two ways. One way is you add the 28 to the 84, right? Like 112. That is
Oh,
one way of doing it. The next way of doing it is you just add in the 28, you added all the numbers that come before the 28 with the 28, and you get the 112. Why we add the first way I show you where we add in this 84 to the 28. This 84 refers to when you add up all of these numbers here, right? So you already add up all of these numbers and get 84. So then we add the 84 to 28 to get the 112. You follow?
oh, yeah. Is this zigzag thing?
Yes, it is the exact thing that remember when we do it in class, when we do this zigzag, yeah, that,
Yeah.
right? So that is one way of doing it, or as I say, if you forget about that zigzag, just go and add all the numbers. So when we want to do this one here now, if you forget this zigzag, 112 plus 8 is 120, just go and add all the numbers to this 8. 8, 28, 29, 30, 18, and 7. And we will still get the same answer. Right?
Yeah.
Okay, good. Right. So when we finish plot the curve here now, use your diagram to find an estimate for the median mass of the newborns. Right. So median, when we're doing median from the table, we know we would use n plus 1 over 2, right? When we have it on a cumulative frequency curve, to find median, we just going to say is a half n, or n over 2, same thing, right? So it is a half multiplied by n. N is what? N is the total frequency. So in this question, the total frequency was 120. So it's a half multiplied by 120, which is 60. So again, remember, this is not your answer. This is the position of the median. So once we have our cumulative frequency curve, we need to find what the 60th value is. So we will come onto the curve, find where the 60th value in your frequency is, make sure and draw your lines on the curve. They want to see your lines like this, right? If you make a mistake down here and write the wrong answer, once you have your lines like this and they see, okay, that person know what they're doing, they will give you your marks still, right? So the 60th value, when we come and read it from our graph, we could see is 5.5. So our median mass is 5.5 kilograms. Right, so there are quite some other stuff that asks, quite amount of other stuff that asks using the graph, and I think that will be covered in the next question that we're going to look at, right? The curve, Annie? The plot curve? Yeah, we don't finally get a value, was it? Why that curve looking shaky so bad? Let's try and draw a smooth curve now. Let me show you though. Yours are not looking a little shaky. Right. Any questions on this one? No? Alright. Alright, so we had two more questions to look at. Let me see where's the time. Alright, good. Right, so now we're going to look at Jan 2022. Now this question, they give you the curve. When they give you a curve, you could breathe a sigh of relief, like less time you're going to spend in an exam, right? When you have to draw a curve like the previous question, that just take a while. So this question, they give us the curve and they're going to ask questions from it. So what we need to do is to know how to interpolate from the curve based on the questions being asked. So this one, how many students walk at most 1 kilometer to school? And then what they ask again here. They want to find median, lower quartile, interquartile range. Then they have a probability question. And then they want us now to fill out this table but we need to get the information from the curve, right? So, right, so let me work on it again, all right? First up here now, they ask how many students walked at most 1 kilometer to school on that day. So we come on our curve and we locate where 1 kilometer is. 1 kilometer would be here. This is your distance. You locate where 1 kilometer, you draw your line coming up, and where it bounces the curve, you come across and you read out that value. Right, so first up, that I leave out just now, we have to make sure and know what the small boxes here would, right? What's the value of them? So let me calculate that first. So the difference between two numbers here, so let me start. So the difference between 0 and 0 0.5 is 0 0.5, and if we divide that by 10, that is 0.05. So each of these small little blocks is 0 0.05. So that means two of the blocks will be 0 0.1, right? And in this direction, in your y-axis, between 0 and 20, we have 10 blocks. So 20 divided by 10 is 2. So each of these small blocks in your y-axis here is 2. So 2, 4, 6, 8, 10, 12, and so on, right? Okay, good. So here they ask how many students walk at most. So at most means that is the maximum the students walk. So they walk 1 kilometer or less. So what we're interested is this part of the curve. So how many students walk up to this point? We come across here and we read that off. So this would be 30, 32, 34, 36. I see not correctly, right? Yeah, 36 students. Right, so 32 students walked at most 1 kilometer. If the question was at least, right, that means who walk 1 kilometer or more. So then we would have do the same thing, draw the line here, but more than one, right, would have been this part of the curve, the top part. So to get that part of the curve, we will take this value and subtract it from the total, which is 120, to give me how much students up here, right? But that's if it was more than. All right. Use your cumulative frequency diagram to determine an estimate for the median. Right, so just like what we just did, median is a half n. Another word for median in the cumulative, they could say Q2. What is Q2? So Q2 or median is the same thing, which is a half n. A half, how much was n in this question? N is your total frequency, which was 120 again, which is 60. So you want the 60th value. So you go back to your graph. We want to locate where the 60th value is. 60th value here. You come across. It bounce up and here. They come down and you read that. That is 1.3 kilometers, right? And make sure this is 1, 1.1, 1.2, 1.3. Yeah, at 1.3 kilometers. Again, I repeat it, make sure and draw these lines, right? Draw them line, you get your mark. So your median here is 1.3 kilometers. From your graph, we get 1.3 kilometers. Right. Next up, they ask to find the lower quartile. Your lower quartile, the next name for lower quartile is Q1. And lower quartile Q1 is a quarter N. Right? So let me do a quick recap on this now. They could ask for median, which is Q2, which is a half N. Right? Find a half N, get that value, read it off from your graph, and we get what we median or your Q2 is. Quartiles now, they could ask for the lower quartile, which is Q1. They could ask for your upper quartile, which is Q3. The lower quartile is a quarter N. The upper quartile Q3 is 3/4 N. Right? They could ask, we'll look to ask right here, the interquartile range. The interquartile range is when you subtract the Q3 and the Q1 values. And then they could also ask for your semi-interquartile range. Semi-interquartile range is when you take your interquartile range and divide by 2. Alright, so let me go look at your lower quartile. Your lower quartile is a quarter N. N is 120. So that is 30. So it's your 30th value. So we come back in our graph and locate where that 30th value is. Right. So this is 20, this is 4, so the 30th will be here. You come across, bounce the curve, come down, and read out that value. So this is 0 0.5, 0 0.6, 0 0.7, 0 0.8, 0 0.9. So Q1 or lower quartile is 0 0.9. So 0 0.9 kilometers. We'll draw the line again. We'll draw the line already and get it? Yeah? Ashley? You know, drawing it along? Alright. Right, and you read out the value then is 0 0.9, right? And then they ask now for interquartile range. So I just mentioned that, right? Interquartile range is Q3 minus Q1. We already worked out Q1 up here as 0 0.9. So now we need to find what Q3 is. So Q3 is 3/4 N. Right? Q1 is a quarter N. Q2 is a half N. Q3 is 3/4 N. So 3/4 N is 120. 3/4 120 is 90. So it's the 90th value. Right? 3/4 by 120 is 90. So now we go back to our graph again. And now we're looking for the 90th value. 90 is up here. Come across. Bounce the curve. Come down. There. Right? That is 1 point. This is 1.5. And remember, each of these small blocks, I can write that down, is 0.05, right? So this is hitting the first block. So that is 1.5 plus 0.05. So that is 1.55. They give a little difficult scale on this one. Alright, so that is 1.55. So Q3 is 1.55 kilometers. And the interquartile range is what they're asking for. It's Q3, 1.55, subtract our Q1, which is 0 0.9, and that will be 0 0.65 kilometers. Right, so the interquartile range is 0 0.65 kilometers. Right, another thing they could ask for semi-interquartile range, right? They could ask, don't ask for none of these things, and just ask for semi-interquartile range. But from that, That means we need to still go and do all of this working. We need to find what Q3, we need to find what Q1 is, we need to subtract it to get the interquartile range, and then when they ask for semi, we have to take this final answer and divide it by 2, right, if they ask for that semi-interquartile range. Right, part C, the ask is student is chosen at random. What is the probability that the student walk for more than 1.5 kilometers? Right, so we come back to the graph now and they want more than 1.5. So we locate where 1.5 is, which is here, and we come up. We bounce the curve, we come across. Right, and here is 82. Right, so if we understand what this curve telling us, this telling us that 82 students walk 1.5 kilometers and less, because this 82 refer to this position and below, but they want more than. So to get more than 82 would be the above portion of this curve, and the above portion of this curve will be 120 subtract the 82 will give us how much above here, right? So 120 take away 82. So it'll be 120 take away 82 over the total. The total is 120. And that will be 19 over, let me see, it was 38 over 120. And then you reduce that will be 19 over 60. Right, so the probability that a student walk from more than 1.5 kilometers to school will be 19 over 60. Right, so remember when they ask for less than, you take the exact value from the curve. If they ask for more than, you need to take that value and subtract it from the total. Right? Alright, this question still going on. Complete the table below and use the information to calculate an estimate for the mean distance walked by the students on that day. Right. So this question is a reverse question to what we just did. You have the curve and you have to figure out what the frequency and thing is in the follow-up here, right? So first up, we could follow this midpoint. Midpoint, we add these two numbers and divide by 2. 1.5 plus 2, like 3.5 divided by 2, like 3.75, right? Sorry, 1 point, wait, 1.75. Yeah. Right, so we add the two numbers and divide by 2, we get 1.75. Now we have to know how to follow this table here. Where we get this frequency from. So what we need to do, we need to go on the graph and read what happening between 1.5 and 2 to get the total frequency for it, and read what happening between 2 and 2.5 to get this frequency for it, right? So that's the thing about these Jan questions. I like to ask this kind of reverse question. All right. So we want to know between. So let me start from this one first, right? Between 2 to 2.5. Right. So between 2, which is here, and 2.5, which is here, right? This part of the curve given us how much students between 2 to 2.5. So we need to get this value here. This value here is 118. Is it 118? That's 110, 12, 14, 16. So this value here is 118. And this value here is 112. Right? So if here is 118 and here is 1112, the amount of students between these 2 points will be 118, take away 112, so we will get 6. So we have 6 students between 2 to 2.5. Right, so we have 6 students here. Then the next one they ask for is between 1.5 and 2. So between 1.5 and 2, let me erase this so I can see. So between 1.5, which will be here, that is how much? Oh, we had that one, that is 82. So this is 82. Right? So between 1.5 and 2, so that is between 82 and 12, we would have 30 students. Right? So this part of the curve, we have 30 students. So we have 6 and 30. So we could fill that out into the table now. So we have 6 here and we have 30 here. Right, and now we could work on the rest of the question. 1.75 times 30 is 52.5. 2.25 times 6 is 13.5. And then the one, the mean, don't forget to work the mean. The mean is sum of fx over sum of f. Sum of fx, we total up this here, and we total up this, what we get? 150. And the total frequency, where we know that from before, is 120, right? So we don't have to total it up. So your mean would be 150 over 120, which is 1.25 kilometers. I think that's the end of this question. 3 marks, but yeah, at the end. Right, any questions on this one?
No.
All you understand how to extrapolate from the graph to get the frequency, right? You find between the 2 points. In case they bring that reverse type question. Zahara, how are we going with these questions? And Zana, I hear from you all for a while.
Good so far.
Very good. All right. Okay, so we have one more question to do. If you have no questions on this, let me see what the next one. The last one I think was a histogram, right? Yeah. Right, so this question now, this is what? May 2019 question 5. So this is where we have boundaries. They ask for boundaries, and they ask for class width, and then they ask for how much is recorded, a probability question, then they ask for median, and then they ask us to represent the histogram, draw a histogram, right? Right. Right, so before we start the question, let me run through what is type of question is this. So this is a group data. Why is that group data? Because we have intervals here, right? We have intervals here. So some things they could ask for our boundaries and limits. So let me quickly recap what are limits and boundaries. So your limits is basically the numbers you see in here. This is what limiting each of these intervals. So if you ask for lower class limit and upper class limit, which they could ask for in paper 1 and even paper 2, your lower class limit for this first interval here is this value, which is 11. And the upper class limit is this value here, which is 20. Right? Your limits are the actual numbers in the interval. Then they could also ask for boundaries. Your lower class boundary and your upper class boundary going to be the difference or the middle of these two numbers. So if this is 20, right, and the next interval is 21, we have to have something to take into account what's missing between 20 and 21. So what they usually do for the boundaries is just add 0.5 to the limits and subtract 0.5 to your lower limit. So your lower class boundary here will be you subtracting 0.5 from 11. So that will be 10.5, and you're adding 0.5 to your upper class boundary, to your upper class limit, so that will be 20.5. Right? So your limits is the actual values in the interval, and your boundaries is when we subtract 0.5 on your left hand side and you add 0.5 to the right hand side. Right? Now, sometimes our boundaries and limits could be the same, and the only time it could be the same is if these two values are the same. So for instance, if this wasn't that, if this was 20 to 21, this 20 and this 20 here is the same number, so we can go and say 20.5 as a boundary. In this case, our limit and boundaries are the same, right? Because it's the same number, right? So don't let that confuse you. Sometimes there's ask that as well. But in this case, it's different because we have a 20 and we have a 21, so our boundary is we're going to add the 0.5, right, and subtract the 0.5. All right. So that was a quick recap on boundaries and limits. So let me see what the asks here. For the class 21 to 30, determine the lower class boundary. So they're interested in this one here, right? The lower class boundary is where we would do what? We would take away 0.5 from 21. So this will be 20.5 liters. Right? This is our lower class boundary. Then they ask for class width. Alright, I didn't mention that just now, I know it was coming up. Class width is the width of your interval. Right? They want the width of this interval here. So since they want the class width for 21 to 30, the class width is given by the difference with your boundaries. Your upper class boundary take away your lower class boundary. So for 21 to 30, the upper class boundary, we would add 0.5 to this, right? So that's 30.5. Take away your lower class boundary, which is 20.5. So your class width will be 10. When you subtract those two numbers, we get 10. Right, so though that cover a little bit on boundaries, limits, class width. Let's see what next. How many vehicles were recorded in the class 31 to 40? So we go back to the table. They want to know how much vehicles are in this class 31 to 40. Right? So you all think it's 101? Well, let's see that number. You all think is that? Justin, you think it's 101?
No,
No. Why is not 101?
because what explain
Because the
is
heading.
more than that.
No, what's the heading? The heading is what?
Cumulative
Cumulative
frequency.
frequency. So this 101 represents how much come before and it as well, right? So since it's cumulative frequency, we need to find the frequency. Right? So this is another type of question that is put it in reverse. So to find your frequency, to find cumulative frequency, we would have been adding the frequency. Let me repeat myself there, right? I'm confusing myself here. To find the cumulative frequency, we would find this running total of the frequencies, right? We add up all the frequencies to get cumulative frequency. Now, if you're given the cumulative frequency, the find frequency, we have to do the reverse. We need to subtract. So you start at your bottom here now, and here to get this number, we would subtract these two numbers. So 150 take away 129 will give me this first number here, and I21. Then to get this number, we subtract these two numbers here now. 129 take away 101, we get 28. To get this number, we subtract 101 and 59, and we will get 42. To get this missing number, we subtract these two numbers, 59 and 24, and that is, 35. And then to get this last number, we subtract 24 and what comes before it 0. So that will just be 24. Right? So once we have cumulative frequency, to find frequency, we need to subtract the numbers. We're going backwards. And if you want to double check, just come back and add up now and make sure we get the same thing. 24 plus 25 is 59, plus 42 is 101, plus 28 is 129, plus 21 is 150. So we know we're correct, right? Right, so now we convert the cumulative frequency back to frequency. Now we can answer the question. How many vehicles were recorded in the class 31 to 40? So 31 to 40, we had 42 vehicles. Then a vehicle is chosen at random from 150 vehicles. So it's from 150, so we know it's over 150 one time, right? What is the probability that the volume of petrol needed to fill its tank is more than 50.5? Leave your answer as a fraction. So more than 50.5, if we go back onto the table, right? So look at your frequency, right? Up to 41 to 50, we had 28. More than 50.5 would be over here, right? So this is 50 and less. So more than 50.5 would be this one. So we have 21 vehicles who is more than 50.5. So that would be 21 over 150. And leave as a fraction, so you just reduce it to the lowest term, which would be 7 over 50. Right, so 7 over 50. Brian estimates the median amount of petrol to be 43.5 liters. Explain why Brian's estimate is incorrect. Right, so these are smart way of getting you to actually calculate the median. So what do we have to do? We need to calculate the median and see if this value that this person estimates fallen in the median. Right, so median is n plus 1 over 2. N is what again? N is the total frequency, which is 150. So that is 75.5. Right? So it is 75.5 value. So we need to go on our table and see where 75.5 value. Right. So we have 24 and 35, which is 59. So we have the 59th value within 21 to 30. And then 59, and then we go 59, and then we need to add 42, which will be 101. So we have the 60th all the way to the 101 value between 31 to 40. So therefore, the 75.5 value will be between 31 to 40, right? Because 59 is 21 to 30. So I'll just say 60, 61, 62, 63, all the way up to 101 will be 31 to 40. So therefore our median is 31 to 40. So based on calculation, the median is 31 to 40 liters, right? That is the median. And his estimate was 43.5. So he is incorrect because 43.5 liters, which is his estimate, is not within the median. Right? He's incorrect because 43.5 liters, which he calculated, is not within the median. Right? The median is 31 to 40. So he overestimates. Right. And then last up, we had to construct a histogram. On the partially labeled grid below, construct a histogram to represent the distribution of volume of petrol needed to fill the tank of 150 vehicles. Right, so you have to remember the difference between a bar chart and a histogram, right? Okay. A bar chart is when we have the bars separate out with a space in between, right? And a histogram is when we have no spaces. The bars are joined. So, and the height of the bar is our frequency. So we need to figure out what is the x-axis here, right? So the x-axis here would be the petrol. So in a histogram, it's going to be volume in liters. In a histogram, what we will put in the x-axis here, we will put our boundaries. So we will put our lower class and upper class boundaries, right? So in this question, our boundaries is 10.5. So I will put 10.5 here, and then 20.5, and then 30.5, 40.5, 50.5, 60.5. We're going up to 60.5 and then 70.5. Right, so we look at the intervals in the table, right? So the first interval is 11 to 20, right? But we need to put boundaries for histogram, right? So it's 10.5 to 20.5. And what you could do, since we didn't start exact here, just put a line here and put a broken line here, right? To show that we start off as a broken. Right, so you could do it like this, or you could actually leave this as 10, 20, 30, and then actually draw a histogram at 0.5, which is here, right, in between here. But once you show this break here, you tell them, I ignoring this part of the scale, and I just started with 10.5, which is here. Right, so now we have our boundaries, so we would look at the table and get the frequency. So the first one that between 10.5 to 20.5 was what height? I have it in the table there. I don't want to scroll back. That's 24. Right. So the first one between 10.5 and 20.5 had to go all the way to 24. So this is 20 and this is 30, so this is going in 1, right? 21, 22, 23, 24, 25, right? So we would count all the way up to 24, 20, 21, 22, 23, 24. So it's here to here. and we draw our first bar going up. Right, so the first bar we have at height 24 is between 10.5 to 20.5. The next bar now, which is between 20.5 and 30.5, was a height at 35. So we need to go up to 35. 35 is here. Right, that is second. Then the third bar, which is between 30.5 and 40.5, is 42. So we'll go up to 42 now. This is 40, 41, 42. And obviously you always do this with a ruler neatly, right? So we had 3 bars. The fourth bar between 40.5 and 50.5 is 28. 28 is 25, 26, 27, 28 will be here. And then the last one between 50.5 and 60.5 is 21. So that will be here, right? 21 right here. Right. That was it. So if you remember when a histogram, you need to put your boundaries as your x-axis, right? Not the actual limit, not the actual limit values, your boundaries, your class boundaries, lower and upper class boundaries. Right, that was the end of this question. Yeah. You finished, right? Hmm? Can't find a number?
No, actually 2 more.
Oh, okay. All right. Online, any questions?
No, sir.
No. All you more or less good with statistics now? Or you have to review some stuff still?
Just had a practice.
Okay. All right. So as usual, I record the session. I hope it come out all right. So I'll go post it up. So when you are practicing again, you can look back at it if you forget something, right? More or less, I think we cover. I don't want to say 100%, but I believe we cover at least 95% of what is usually common statistics, right? The majority of things that is usually come, we cover. So it's just for you all to practice. And as I say in the beginning of class, statistics is a question where you could get at least all your marks in once it come how it is usually come, right? All right. So next, if nobody have questions, next week class, I think is the last topic I need to do in questions, right? Which is question trees. And question trees is have construction. It could have some trigonometry, and then it could have geometry, which is like transformations, right? So for next week class, I think you all have to have, again, by tomorrow, so I'll go post what questions to print. I think most of them you might have to print if it's transformations to do it, right? Our next thing I did, and I will post on the Google Classroom probably later or tomorrow, I did some forms for the multiple choice questions for the past 7 years. So that I think 2019 to 2025 May, June. I did some forms. So when you have your paper and you're doing the questions, you could open the form and actually do it on the form. Just select A, B, C, whatever is your answer. and when you finish, you submit, and it will automatically tell you what's your score, and they will give you the not the solution, they'll give you the answers for what the correct answer is. So let me say you get 2 wrong, they will tell you what the 2 answers are supposed to be. So you can take note of what it is, and then when you're redoing the question, you will know what it is. And you do that enough times, last 7 years of papers, supposed to be able to get over 55 in your paper 1. Right? So I will post them forms sometime tonight or tomorrow. Right, so if nobody has questions, we wrap up. See you all there next week. Have a good week revising. Bye, everybody.
Bye.